Hi everyone, this is the trigonometric identity questions, like a proof and simplify. Before we start, I hope you have a high motivation and high confidence and zero fear. Let's have a look at the first question. Part A, simplify sine 2x over 1 plus cos 2x. Okay, so what that really means, we need to sort of use a double angle here and then cos 2x as well. So let me sort this out. It'll be on the top with 2 sine x and cos x. If you don't know or you don't remember of these double angles, please go back to my previous questions for all the proofs and the rules, and then memorize it if you can. Now this is 1 plus cos 2x is what? 2 cos square x minus 1. Yeah, that's what you're gonna get. And if I sort of simplify that, x over, now if I expand this one, I'm going to cancel this 2x, and then I'll go cancel, 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 cancel. I'll get sine x over cos x. It'll be tan x. Okay, now with that, hence, so that means most of the times when it says hence, you need to use the previous proof or previous question answer or solutions. So using that, we need to find the exact value of 10, 15, because the 10, 15, we don't have a exact value for this, but using this method, we might be able to do it. Well, we will do it. So let's have a look. So let's have a look at that, 10, 15, and using that formula from the part A, 2x, so it'll be 2x is 15, and 1 plus cos 2x 15, so that will be sine 30, and 1 plus cos 30. Okay, now we are talking, because we can find the exact values of those. That's not a problem. So that's what? Half, and that's root 3 over 2. So if I put all that in, 1 plus root 3 over 2. Now, I'm going to sort of sort this out on the bottom because we got a double fraction happening here. 1 plus root 3 over 2. I'm going to make everything common denominator as a 2. It'll be 2 plus root 3. So if I put that in, 2 plus root 3 over 2, that will actually cancel that out. It's a nice skill to learn. 1 over that on that left, so it'll be 2 plus root 3. And we want to do rationalizing denominator, so conjugate pair we're going to use. Oops. So what do we have? Now that's a difference of 2 squares. It's going to be 4 minus 3. So my final answer is 2 minus root 3. Okay, so that's my final answer. All right, so that's done. Next one, prove that sine square theta equals half sine 2 theta and tan theta. So I'm going to go with, I can't really do much about left hand side, so I'm going to go with the right hand side equals half. Now sine 2 theta is what? It's 2 sine theta cos theta, and I'm just going to change that tan theta because on my left hand side I don't see any tan there, so I'm going to do sine theta cos theta because tan theta is sine theta over cos theta. So when I do that, I can cancel this out. I'm left with sine square theta, which is the same as my left hand side. Okay, so that was too bad. Now, next one. Let's have a look at this. This one, as soon as you see x over 2, you should have some sort of the feeling coming to you saying, I need to use t formula. Yeah? And if you did, well done. So I'm going to go let t equals tan x over 2. And I'm also going to use that the triangle. I know there's a few ways of memorizing this, but I like to remember this way. And I'm going to go left hand side is 1 plus sine x minus cos x all over 1 plus sine x plus cos x, and I'm going to replace all this with the t terms. So 1 plus sine is 2t over 1 plus t square minus cos will be 1 minus t square over 1 plus t square all over 1 plus 2t over 1 plus t square plus 1 minus t square over 1 plus t square. And then I'm going to have to work on the find the common denominator and on the numerator part. So my common denominator is 1 plus t squared, and for this one I'll get 1 plus t squared plus 2t minus, I'm going to put in a bracket, 1 minus t squared. Okay, and then on the bottom here my common denominator is also 1 plus t squared. So I'm looking at this right now. So it'll be 1 plus t squared plus 2t plus 1 minus t squared. It's easy because they both have common denominator 1 plus t squared. Only thing we have to change is 1. 1 will be just 1 plus t squared over 1 plus t squared. So that's not too bad. And I'm going to cancel this out. I've got left with 1 plus t squared plus 2t minus 1 plus t squared all over this one, 1 plus t squared plus 2t plus 1 minus t squared. Okay, now let's see if I can cancel some of the things. Yes, I can. So it'll be 2t squared plus 2t. This one, 2 plus 2t. Okay, that's what I've got. And if I take all the 2's out, I can make a t squared plus t over, I'm going to write it like this, t plus 1. And that also, if I take, t plus 1, and then t plus 1 is t, which is, we said, t equals 10x over 2, which also means it's same as a right hand side. So we prove that as required. Okay, and next one, question 3. Let's have a look. Question 3, find expression for sine 2a minus cos 2a, and in terms of t, 10a over 2. Now that's what this is similar to the previous one, but again I'm just going to do that triangle, 2t, 1 minus t squared, that's correct. Okay, so now I'm ready to do the proof expression, find the expression. Okay, so before I start, I'm going to go sine 2a minus cos 2a equals, what is it, 2 sine a cos a minus this can be written as going to go cos square a minus sine square a. Okay, so if you didn't know that, go back and have a look at the my other video, and it'll talk about the proving of some. Okay, so I'm going to go to this one. I'm going to use this one to prove this. So use 2 sine a cos A minus cos square A plus sine square A. And then I'm going to use all these t terms, okay, minus square. I'm going to just setting up so that I don't have to think about it. So sine A will be 2t over 1 plus t squared. Cos will be 1 minus t squared, 1 plus t squared. And then cos squared will be 1 minus t squared, 1 plus t squared, 2t, 1 plus t squared. Okay, so, that's not too bad. I'm going to go 2 times 2t, 1 minus t squared, all over 1 plus t squared squared. Okay, and then these ones, luckily, it looks like we're all going to have same common denominator, which will be square square. Okay, so, and I can just make the whole thing into one fraction. So this one will be 4t, 1 minus t squared, and then I'm just going to expand this 1 minus 2t squared plus t to the power 4 plus 4t squared. Okay, and then I need to expand a little bit further. So it'll be 4t minus 4t squared. Oh, nope, cube minus 1 plus 2t squared minus 4t. Nope, there's no 4. To the power 4 plus 4t squared. Okay, that looks okay. Let me check quickly, and I want you to check that as well. And if I think I did all right, and then I'll go minus t. I can see this one, I can simplify it, nothing else. So I'm going to go 4 minus t to the power 4 minus 4t. I'll just write it in a order of the power. I mean, you can write it in any other way in making it a positive, but I'm just going to do it like this. So that's my answer. Okay, so next one, last question, guys. Last question. So prove that cos 3 theta equals 4 cos cube theta minus 3 cos theta. So let's have a look. I'm going to go with the left hand side this time. Now, cos 3 theta, I'm going to write it into cos 2 theta plus theta. And I'm going to use double angle for this. So to be, remember, cos 2 theta cos theta minus sine 2 theta sine theta. Okay, and with this, we can write it as a cos square theta minus sine square theta cos theta minus, what's this one? 2 sine theta cos theta, and this sine theta. Okay, and then I'm going to expand this one. It'll be cos 3 theta, cube theta, minus sine square theta cos theta minus 2 sine square theta cos theta. Look at that, the same term. So I'm going to go cos cube theta minus 3 sine square theta cos theta. Now, when we look at this and then what we have to prove, there's no sine terms in the right hand side. These need to be same as this. So we got cos cube, that's no problem, but we don't have a sine square. So I need to change these in terms of cos. So cos cube theta minus 3, which will be 1 minus cos square theta cos theta. Now, how do I get that? Is this, guys, do you remember the identity? Plus cos square theta equals 1. And now if I make it cos square theta as my subject, it'd be 1 minus cos square theta. So that's why I put that in there. So expand this. 3 3 cos theta, I forgot this one, plus 3 cos cube theta. So I've got 4 cos cube theta minus 3 cos theta, which is exactly the same as this. So that will be my right hand side, and done. Okay, so that's number 4. I think we've done it. Okay, I just want to show you something. Cos to theta is like this, isn't it? Cos theta plus theta. So when we do this, cos theta minus sine theta, which will be cos square theta minus sine square theta. Okay, that's what happens. Now that's one thing, but if there was a if I change the sine square theta to 1 minus cos square theta, okay, because that's what we can do, and that will give me equals 2 cos square theta minus 1. Okay, that's one thing. But what if I changed it to this one, to 1 minus sine square theta, and then go to sine square theta? I will get 1 minus 2 sine square theta. Okay, so in having said that, so cos to theta is quite flexible, you know. We can write it as cos square theta minus sine square theta. Also, we can write it 2 cos square theta minus 1. Also, 1 minus 2 sine square theta. Okay, so all these is coming from, of course, cos square theta plus sine square theta equals 1. Don't forget that. Okay, well done.